Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 2 video on the chapter of heat transfer, where I will be solving 5 multiple choice questions based on the concepts of linear expansion of solids that are discussed in part 1. This video this video is part of the playlist ICSE Physics for class 8, where I primarily discuss about the key concepts and formulas related to numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and once again, if you want to further support me, then subscribe to my channel, and in that case, do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 2 video, where I will be solving 5 multiple choice questions based on the concept of linear expansion of solids. Okay, sorry, the first problem says that a metallic rod when heated through 1 degree Celsius increases by 1 by 20,000 part of the original length. Then alpha means the coefficient of linear expansion for the substance of the rod is. Okay, so a metallic rod when heated through 1 degree Celsius heated through 1 degree Celsius means that the delta T, that is the increase in temperature when it was heated, the temperature by which the metallic rod, the temperature of the metallic rod increases by 1 degree Celsius. So delta T is 1 degree Celsius. It says that a metallic rod when heated through 1 degree Celsius increases by 1 by 20,000 part of the original length, which means that the delta L, that the increase in length, is equal to 1 by 20,000 part, that is 1 by 20,000 part of the original length of the metallic rod, which we do not know. Let's say the original length be L, which is equal to, we can say, L by 20,000. Okay, we have to find alpha. So we know that the fundamental formula the fundamental formula of linear expansion of solid is delta L, that is the increase in length, is equal to alpha multiplied by L multiplied by delta T, where alpha is the coefficient of linear expansion of the material of the rod, L is the original length of the rod, and delta T is the increase in temperature. We have to find alpha. So we know that alpha is delta L divided by L multiplied by delta T. Now this delta L we know is given, delta T is 1 degree Celsius, and this is not delta T but delta L is will be L by 2000. So delta L is L by 20,000, and then we have divided by L, and delta T is given to be 1 degree Celsius, so it is 1. So LL cancels out, and we have this to be 1 by 20,000, which is equal to half multiplied by 10 to the power minus 4. This should be actually per degree Celsius. Okay, this after simplification becomes 0.5 multiplied by 10 to the power minus 4 degree per degree Celsius, or this is equal to 5 multiplied by 10 to the power minus 5 per degree Celsius. There is no choice. I think I did a mistake in giving the choices. Let me check again if my calculation is correct or not. Alpha is delta L divided by L multiplied by delta T. Delta L is given to be 1 by 20,000 part of the original length. So L by 20,000. Okay. LL cancels out, so this becomes, delta T is 1 degree Celsius, so this becomes 1 by 20,000. This is correct. So 0.5, yes, this should be the linear coefficient of linear expansion of the substance of the rod. I did a mistake. I forgot to give the choice 5 multiplied by 10 to the power minus 5. Anyway, so the coefficient of linear expansion is 5 multiplied by 10 to the power minus 5 per degree Celsius. Let's see the next problem. A metallic rod of substance A, when heated, expands to x times of original length with an increase of T1 degree Celsius in its temperature. Another rod of substance B, when heated, expands to y times of original length with an increase of T2 degree Celsius in its temperature. If alpha A, alpha B are the coefficients of linear expansion of A and B, then find alpha A is to alpha B. Okay, so let's see for the case of substance A, what do we have? It is given that the metallic rod of substance A, when heated, expands to x times of the original length. The original length is not given. So if I consider L to be the original length, then the delta L, that is the increase in length, will be equal to increase in length. It is saying that a metallic rod of substance A, when heated, expands to x times of original length. That is the final length after expansion is x times the original length. So delta L will be XL, x where I am assuming L to be the original length of the metallic rod of substance A. Then after expansion, its length will be XL, and its original length was we have assumed to be L. So this is the increase in length. And what is delta T? Delta T is given to be T1 degree Celsius. Okay, so let's see for B, for the substance B, it is given that another rod of substance B, when heated, expands to y times of original length. Okay, so for B, delta L will be, if I consider L dash to be the original length of the rod of substance B, then the increase in length delta L will be y L dash minus L dash, and delta T is given to be T2 degree Celsius. Okay, so now for A, alpha A, we know will be delta L divided by L multiplied by delta T, which will be equal to delta L is XL minus L divided by L, delta T is T1. So this much per degree Celsius. This, if I take L common from the numerator, I have L into x minus 1 divided by T1 L per degree Celsius, and this is equal to L cancels out, and this becomes x minus 1 divided by T1, this much per degree Celsius. Similarly, for the substance B, we will have alpha B, we know is delta L divided by the original length we have assumed to be L dash multiplied by delta T, which is T2 degree. this much per degree Celsius. Now delta T is y L dash minus L dash divided by L dash T2 per degree Celsius. This, after simplification, L dash will cancel out from both the numerator and the denominator, and we will have y minus 1 divided by T2 per degree Celsius. So now we can easily find the ratio alpha A is to alpha B will be equal to alpha A by alpha B. This is equal to x minus 1 divided by T1 per degree Celsius divided by y minus 1 T2 per degree Celsius. Per degree Celsius cancels out from both the numerator and the denominator, and we have T2 multiplied by x minus 1 divided by T1 multiplied by y minus 1. This is the ratio of alpha A and alpha B. So the correct choice is, you can see, correct choice is B. B is the correct choice. Okay, let's see the next problem. Question number 3. A metallic wire of length x meter is heated to raise its temperature by y degree centigrade. If Z if Z per degree Celsius is the coefficient of linear expansion of the wire material, then expanded length of the wire is. We have to find the final length of the wire after expansion. What is given? The original length of the wire, metallic wire, is given to be x meter. Also we are given the delta T. Delta T is given, that is the temperature, increase in temperature of the metallic rod when heated, is given to be y degree Celsius. Okay. Also the alpha, that is the coefficient of linear expansion of the material of the metallic wire, is given to be Z per degree Celsius. We have to find the final the length of the wire after expansion. So for that we need to find first what is the delta L, that is the what is the increase in length. Delta L we know is alpha multiplied by capital L multiplied by delta T. Okay. This is equal to, alpha is given to be Z, L is given to be X, and delta T is given to be Y. So delta L should be this much meter. Now be careful with while using the units. Let me also mention the unit, so you will understand that delta L, the unit of delta L is actually length. So alpha is Z per degree Celsius multiplied by L is x meter multiplied by delta T is y degree Celsius. So as you can see, per degree Celsius and degree Celsius cancels out, so we have Z by x this much meter. This is the increase in length. So the final length, then the expanded length of the wire, or the length of the wire after expansion, will be L plus delta L, which is equal to L is given to be x meter plus delta, sorry, not delta T, but L plus delta L is the expanded length of the metallic wire. L is given to be x meter, delta L we have found to be Z y x meter. From here if you take x common, we have x multiplied by 1 plus zy this much meter. So x into 1 plus zy is the meter, is the final length of the metallic wire, or the expanded length of the metallic wire. So the correct choice is choice D. So choice D is the correct answer. Let's see the next problem. Question number 4. A metallic rod X, when heated through delta T degree Celsius, linearly expands by a length of Lx. Another rod Y of same material as X and having length 1/3 as of X, when heated through twice of delta T degree Celsius, linearly expands by a length of Ly. Then which of the choice is correct? Okay, so let's see what is happening for the metallic rod X and metallic rod Y. For the metallic rod X, it is given that delta L is given to be, it says linearly expands by a length of Lx. So delta L is Lx. What is delta T? Delta T is delta T degree Celsius. we have delta T degree Celsius. This is the increase in temperature of the metallic rod X when it is heated. Okay. Remember that it is given that another rod Y of same material as X. So the material X and Y, the rod X and Y are of same material. So let's say we are assuming the coefficient of linear expansion of the material to be alpha. Okay. Now for the rod Y, we are having delta L increase in length for the rod Y is given to be L Y, and the delta T, okay, let's do one thing. Delta T is twice of delta T degree Celsius. Okay. And also, since the rod X and Y are of same material, the coefficient of linear expansion will be alpha. Now we have in all the given choices, we need to basically compare Lx and Ly. Okay, let's apply the formula of linear expansion for both the rod X and Y. So we know that delta L is equal to alpha L delta T. This is the basic formula. Applying this formula for the rod X, we have Lx is equal to alpha. L we don't know. Let's assume the length of the rod X be L, and we have delta T. Okay. For the rod Y, we have similarly applying the formula delta L equals to alpha. Now the length of the rod Y is given to be 1/3 of the rod X, so we will have L by 3, and also the actual formula is delta L is equal to alpha L delta T. Now applying this formula for the rod Y, we have Ly is equal to alpha L by 3 because we have assumed the length of the rod X to be capital L. So the length of the rod Y is 1/3 of the length of the rod X, it will be L by 3, and the delta T for the rod Y is twice of delta T. Okay. This, after simplification, we have 2 by 3 multiplied by alpha L delta T. Okay. Now see, if I take the ratio of Lx and Ly, Lx divided by Ly is coming out to be alpha L delta T divided by 2 by 3 alpha L delta T. This is equal to 3 by 2. This clearly implies that Lx is greater than Ly. Or we can say that 2Lx, twice doing cross multiplication, we have 2 times Lx is equal to 3 times Ly. Now we have to see the choices. The first choice A says Lx is less than Y. No, that is wrong. Lx is equal to Y is wrong. Choice C, 3Lx is equal to twice Ly. No, that is wrong. And choice D says Lx is greater than Ly. So choice D has to be the correct choice. Let's see the next problem, the last problem. A rod P having alpha equals to x per degree Celsius when heated from T degree Celsius to T1 degree Celsius expands by an amount of y centimeter. Okay. Another rod Q of same length as rod P and having alpha equals to 3x per degree Celsius when heated from T degree Celsius to T2 degree Celsius expands by an amount of 2y centimeter. Then which of the choices is correct? So let's see what is happening for rod P and rod Q separately. For the rod P, what is delta L? Delta L is given to be y centimeter. What is delta T? Delta T, it is given that it is the rod P is being heated so that its temperature rises from T to T1 degrees Celsius. So the delta T will be T1 minus T this much degree Celsius. Okay. Alpha is given to be x per degree Celsius. Okay. The length is not given, but it is given that the rod Q is of same length as rod P. So let's assume that the length of both the rods P and Q be L. Okay. For the rod Q, we are having delta L is given to be 2y centimeter. Delta T will be, since it is being heated from T degree Celsius to T2 degree Celsius, delta T will be T2 minus T this much degree Celsius. And what is alpha? Alpha is given to be 3 times x per degree Celsius, and the length of the rod Q is also L. Okay. So let's see what do we get for the rod P. Applying delta L is equal to alpha L delta T implies y is equal to x L T1 minus T this much centimeter. Okay. And for applying delta L is equal to alpha L delta T for the rod Q, we have twice y is equal to 3x L T2 minus T. Okay. Now for the rod P, we can see that T1 minus T is coming out to be y by xl, and for the rod Q we are having T2 minus T is equal to 2y by 3xl, which is equal to 2 by 3 multiplied by y by xl. Now clearly we can see, comparing T1 minus T is equal to y by xl, and we have T2 minus T is equal to 2 by 3 multiplied by y by xl. So clearly we are having T1 minus T is equal to we will have T2 minus T is equal to 2 by 3 times y by xl. Y by xl we know is equal to T1 minus T. So if we get this equation from here, this is a linear equation in T, and we can easily find out what will be T. So doing cross multiplication, we have 3 times T2 minus T is equal to 2 times T1 minus T. Expanding both the sides, we have 3i's T2 minus 3i's T is equal to twice T1 minus twice T. Bringing all the T terms to the left hand side, bringing all the T terms to the right hand side, and all the constant terms, that is T1 and T2 on the left hand side, we have 3 T2 minus twice T1 is equal to 3T minus twice T, which is equal to T. So this implies that T is equal to 3T2 minus twice T1. So we have found, we can easily find the value of the T, that is the initial temperature of both the rods P and Q. So T is 32 minus 2T1. So the correct choice is B. B is the correct choice. So with this, it comes to an end in solving 5 multiple choice questions based on the concept of coefficient of linear expansion or linear expansion of solids, which are in the shape of rod or wire, which I discussed in the previous video, which was part 1 video. If you find this video beneficial, then please like it, share it with your friends, and once again, please subscribe. Please support my channel by subscribing to my channel, and in that case, do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about the superficial expansion and cubical expansion of solids, and there is a relation between the coefficient of linear expansion, cubical expansion, and superficial expansion. All this I will discuss everything in the next video, and then after that I will solve more problems on the expansion of solids, that is linear, cubical, and superficial expansion of solids. So please stay tuned for all these videos to come soon. I am ending the video here. Thanks for watching, and until the next video, take care and bye.